Scenario: two objects with different rotational inertias are released from the top of the ramp. Both objects have the same mass and travel the same distance. However, the sphere's rotational inertia is less than the cylinder's. Student A argues that the kinetic energy of the sphere is less than the kinetic energy of the cylinder because the sphere will gain less rotational kinetic energy. Student B argues that the kinetic energy of the sphere is less than the kinetic energy of the cylinder because the sphere has a greater acceleration and therefore has less time to gain kinetic energy. Student C argues that the kinetic energy of the sphere is less than the kinetic energy of the cylinder because the gravitational force does equal work on each object as it rolls down the ramp. Explain which student has the correct explanation. The answer: the gravitational force does equal work on each object. Work is equal to the force of gravity times the distance. The force of gravity is what's causing the objects to slide down. Let's say work was 10 joules for the sake of this problem. We know from the work energy principle that work is equal to the change in kinetic energy. So the 10 is going to be equal to the two types of kinetic energy here. Kinetic energy of the rotational plus the kinetic energy of the translational. Here I wrote this. The mgh was the potential. That's what I'm saying the 10G is. The first part, 1/2 I cm omega squared. This is the rotational kinetic energy. The 1/2 mv squared is the rotational, no, is the linear velocity, kinetic energy velocity, right? So this 10 joules can be split into either one of these two, okay? The cylinder will reach the bottom first because it will have more translational kinetic energy. So Ke translational is more, and Ke rotation is less. So it's like the value 7 joules here, and this is 3 joules here. The reason for that is because the rotational inertia is higher than the other object. So the cylinder has higher rotational inertia. Because it has higher rotational inertia, it's less likely to change rotating because that is what the definition of inertia is. It prevents an object from changing. The object started from rest, so it wants to stay at rest. The object was not rotating, so it wants to stay rotating. So the higher inertia from the cylinder means it's going to less likely want to roll. Because it is less likely wanting to roll, more energy is now transferred into the translational kinetic energy. All right, there you go.